Hello and welcome to this video. In this video we're now going to discuss the radioactive waste that comes out of a thermal nuclear reactor. So when we undergo all of this fission reactions and we produce these mass amounts of energy, it's not an infinite energy source. At some point we have to acknowledge the fact that we only have a finite amount of uranium, and so at some point we have to then change the fuel rods. We have to get rid of some of these pieces of equipment that we refer to as spent, because they've used up the mass majority of all of the uranium. And so what do we then do when we have these fuel rods that have been inside a radioactive system for so long? And then how do we safely remove them? How do we safely contain them where they're not going to be constantly emitting radiation to other places? And that's what we're going to discuss in this video. And actually there are three different types of radioactive waste, because different pieces of equipment have had different levels of exposure with the radiation. We have the first and probably the most important ones to handle properly are the high intensity waste. Now, high intensity waste means that they have been exposed to the radiation for the longest time, so they have the highest level of radioactivity. Okay, they, by being present in this kind of radioactive nuclear reactor, they will have been exposed to radioactivity. They themselves become emitters of that radioactivity. Now, the major one that we have are fuel rods, okay, because fuel rods are the sources of this radioactive uranium, which means that as soon as they've been spent, so as soon as they've got rid of all of the uranium that they have, they then need to be removed. Now, in order to do this, how do we actually remove fuel rods? We have to remove them remotely. We can't have anyone going into the thermonuclear reactor and removing it by hand, because then they're getting incredibly close to a bunch of alpha, beta, gamma, heat radiation, all of it. So we have to remove remotely. So fuel rods are removed remotely. And now they will still be radioactive, even if they don't have uranium-235 or whatever fissile material that we were using. They will still be decaying. They will still have some fragments of radioactive materials on their surface or even inside the fuel rod. So they will continue to decay. So they're removed remotely, but they will continue to decay. And so in order to kind of have a safety net from that, we put them in cooling ponds. And cooling ponds are basically just big water baths. So it's a water bath which we place fuel rods or spent fuel rods to absorb the heat given out or the radiation given out by extra decays, because they will still decay. And actually we can have these fuel rods in cooling ponds for about a year. Okay, so they can last in cooling ponds for up to a year. Now obviously we can't have things in cooling ponds forever, because then we'll just have to have massive water baths and then just keep filling them up, and the more we add in the water bath, the water's going to overflow, and it's not really that kind of useful, I guess. One idea that we had originally was, let's just put all this radioactive waste at the bottom of the ocean, and then we will end up with essentially the biggest water bath we can get on Earth, which is the ocean, and it will continue to absorb this radiation. This is now banned. We can't do this because that level of radiation on the wildlife in the oceans is incredibly harmful. So instead we have cooling ponds, and then we say, after they've been cooled down to a relatively safe level, how do we then transport them somewhere else where we can keep them for a long amount of time? And so what we do is we then take them out of the cooling ponds and we seal the rods in drums. Now these drums are steel and then which are surrounded by concrete. Okay, so that they can absorb all of the types of radiation that are coming out. The steel will be able to stop the alpha and beta. The concrete is there to stop the gamma. Obviously, we could put these all in lead containers, but then lead containers themselves are going to be very heavy, very difficult to transport, and also very expensive to make. So we just seal the rods in drums, which are steel drums surrounded by concrete, and we bury them. Okay, we have some sort of area where we can bury in essentially just a rural area, so far away from a city, where it's referred to as geologically unstable, meaning that people wouldn't be able to live there anyway, so we might as well put the radioactive waste there, because then it's not harming anybody. And this can then stay in these kind of containers for centuries, and they will have to, because a lot of this uranium will have very long half-lives, so they will continue to be radioactive for a few thousand years. So even if we're changing the fuel rods every 10 or 20 years, we're still going to have thousands of years worth of fuel rods to actually let them irradiate to an activity level where it's safe. There is also another method of doing this, which is called vitrification. Now, before vitrification occurs, we'll usually first, so we will first of all try and use up any of the extra fuel. This is precious uranium, right? It's very useful, as we've seen in this fission reaction. So we don't just want to have, even if the fuel rods aren't emitting a considerable amount of uranium, they might still have a tiny amount. And then if we're changing the fuel rods every so often, we're then going to be wasting very large amounts of uranium. So the first thing we need to do is kind of see if we can first get, we retrieve any useful uranium. And then vitrification is the process of melting, or we submerge the fuel rods in melted glass and then seal them in drums. Now this obviously serves a very similar purpose to just sealing the rods in drums and then burying them in a rural area, but now we've kind of submerged the fuel rods into melted glass, and that glass then after a few centuries could possibly be dug up and then used as a useful material. And this then gives us this idea of how to react to high intensity waste, this high levels of radioactive waste. How do we actually safely store them? But this is still a major problem, especially in Britain, because nobody really wants to have radioactive waste buried anywhere near them, even if it's a few miles to the north or south or wherever they are. Nobody wants radioactive waste being buried around them. Nobody wants radioactive waste being driven through their city. So the kind of issue we currently have is, where do we put all of this radioactive waste that we're storing? And this is why we don't have a massive amount of nuclear reactors. Even though we can make them and they are very useful as to giving us large amounts of energy, they're still very expensive to uphold. They have some dangers and risks, and when we actually finish with the fuel rods and stuff like this, we have to have some way of disposing of them. This is why we're not currently trying to build as many nuclear reactors as possible on the planet, because we also have nowhere to kind of put this radioactive waste. But this isn't the only type of waste that we have. We also have kind of a mid intensity waste. So we have, let's call it a medium level of radioactivity. So we have medium level radioactive waste. And these are things that are still radioactive. So they will be things maybe such as the control rods, because the control rods have been submerged in this radioactive facility for so long. Maybe after some time we might have to replace the steel walls, but they aren't sources of the radioactivity like the fuel rods are. So they will have a medium level where it is still dangerous to have, but we still can't just throw them away, for example. We still have to keep the level of radioactivity to a minimum. So the way that we deal with the medium level of radioactive waste is we essentially just seal it in drums. Okay, so these are things like control rods, maybe even in hospitals, because nuclear reactors aren't the only radioactive waste we have. Maybe some larger equipment that we have, like X-ray scanners. Sometimes some of the components in an X-ray scanner will have to be doing things like this, maybe the steel wall in the container. And what we do is we just seal the components, or seal the waste, in drums, and then submerge them in concrete. And then they will be held in facilities. They don't necessarily have to be buried underground. They are held in facilities which have built of special walls of concrete. Okay, so it will be a full facility that just has thick walls, and its only purpose is really just to store this radioactive waste. And this is medium level. Now, you might say that this is exactly the same as high level. The only difference is that we don't have to leave these in cooling ponds for a year. We can just take them out, although we will have to take them out remotely still. So still removed remotely. We don't have to wait a year before we can start to seal them in drums. We can remove them, seal them in a drum, seal that in some concrete, throw that into some concrete facility, and leave it. Again, the same issue arises where we don't really have any places where we can build facilities like this that will be functional for a long scale of time. And now the last type of radioactive waste is the low-level waste. Now, the low-level waste is kind of the things that aren't radioactive. They haven't really been subject to radioactivity for a very long time. They will have been in the vicinity of it, but not necessarily in a dangerous way, so they won't irradiate things for any amount of time. This could be things like medical equipment. So maybe if I've just sterilized something with a bunch of gamma radiation, it's then absorbed some gamma radiation, right? So it's still slightly radioactive. So this is mostly things like medical equipment. Maybe things like the mechanisms that you use to move the control rods in something like this, and so forth. But low-level waste isn't that dangerous, but it still has to be handled with care, because if we then expose ourselves to multiple low-level waste sources, we're going to end up with still a high amount of radiation. And this could also be things like hazmat suits, that kind of thing. So a hazmat suit has, again, it is not a, for those of you who aren't familiar with hazmat suits, They are a lead-lined suit that people will use when they're going into a radioactive power plant in order to protect themselves from the radiation. They are lead-lined, which means they absorb the radiation, right? But it doesn't then get re-emitted into your body, but they are radioactive, so they have to be sealed away. And how we work with these, mostly medical equipment can be kind of just radioactive shower or have a radiation shower and then go back into use. But things like hazmat suits are sealed in metal drums, so you don't really need all of this concrete, and they are buried in trenches. So this would be kind of just a deep trench that we could just kind of throw all of this radioactive waste in. So this means that if these are the ways that we currently handle with radioactive waste, what we're basically doing is mostly just causing the Earth itself to kind of gather up all of this radiation that we're using. And this is obviously not good for the environment. It's also increasing the levels of radiation that we have as a background source, because if these things are constantly emitting radiation, we saw in the background radiation video that we can get radiation from rocks in the Earth, and the way that mostly happens sometimes is from this radioactive waste that we're then using, burying it, it's irradiating rocks, and then the rocks are radiating it back out at a lower intensity. So it's not dangerous per se, but it's still not the best way of reacting to it. Some people have come up with suggestions that we could just take radioactive waste and shoot it into space, because that's just open space. It's not really going to harm any environments or planets if it's just floating around. But again, if we're going to take every control rod or every fuel rod or every hazmat suit that we've ever used on the planet and then put it in a spaceship and keep firing it into space, that's very expensive, and it's going to end up costing more to shoot it into space than it will just to bury it. And unfortunately, people nowadays will generally care more about the cost of things, the economic side of things, than they will about the result or the effect on the environment. So because it's more cost effective to do it this way, this is what we naturally do. But what you need to know is these three methods and these three levels of intensity of radioactive waste, you can be asked sometimes in a 6-mark question for you to talk through all three types of these wastes, so high intensity, medium intensity, and low intensity, and how you would deal with each of them, giving examples of what they are. Thank you for watching.